All right, so let's go ahead and start talking about functions. So if you are talking about domain and range, domain all that means is a list of x values. And range is all of the y values. So if okay. And this is not something that you're going to have to come up with or do. This is an explanation of a new set of vocabulary pieces. So if I look at question 1, and a function has one rule. We have for every input, we have exactly one output. And when I say it like that and then go back and say every input, that means for every x value, we have one output. That is my y value. So what I mean by that is the example I like to use all of the time is speed dial. So if you go ahead and have your best friend on your speed dial, when you hit that number 1, that input of speed dial, you only want it to go to one person. You would not want that speed dial to randomly go to your best friend and or your mom, especially at 2 o'clock in the morning, right? So that's this idea is every X has exactly one output. Now the opposite of that, and what that looks like on the map, and that's why I wanted to show you what that map was. This is a domain. And this is the range. That means 1 gets mapped to 3. It is absolutely okay that you have 2 inputs that go the same place. All right? This is a function. It is okay that you have 2 x values or inputs that go the same place. Just like you have speed dial, right? Speed dial, you could hit speed dial, or you could go ahead and type the phone number into your phone. They both go the same place. That's okay. You can have 2 different things that go in that go the same place. What you can't have is one input that randomly goes one place and or another. So if I go through and now look at the next question that I have here, the next question on there is asking, determine whether each relation is also a function. So the best way that I like to go ahead and do that, if I go ahead and look at 2a, the list of points there is 10, 5. My next point is -3, -2, 2, -1, and 6, 5. So I like to do these with a map. Some of you might be go ahead and just go ahead and do them out, but that's fine. So 10 goes to 5. -3 goes to -2. 2 goes to -1. And the last one, 6, goes to 5. So this is a function. Okay, so how do you know that the 10 goes to 5? Well, this is my point, which is my ordered pair of x comma y, right? that means that 10 is linked to 5 as that ordered pair. -3, in order for me to match the ordered pair, the x value has to go to 2. So all I'm saying here is this is my x value of -3, and it goes to a -2. Now, if I added another point, the point 10, -2, would that make this a function or not a function? Well, what would that mean? This is my x value, correct? And this is my y value, which is -2. So that means now 10 could go 2 places, correct? And if I did that, that would make this not a function. Then it's just called a relation. It's just a relation of points. So I'm going to draw a couple different graphs on here. What is the vertical line test? The vertical line test says if you can draw a vertical line and touch the graph in 2 or more places, it is not a function. So if I draw this like this, it touches it here and here, which means it is not a function. Same thing here. Not a function. But the last one, there's no way, even if I drew a couple different vertical lines, right? It would always only touch the graph in one place. So this one is, yes, it is a function. 3, which would give me y would equal to a +1, right? So now we're going to go ahead and use this function notation. That's all. We're just changing the language. So now, if I look at 4a, and the solution online is a little bit, it is incorrect. So 4a says f of x is equal to -1/3 x minus 5, and it wants you to find f of -3. So do know that this question, those two are exactly the same. It's just using a different language. That's all. So this is really saying plug in and let x equal -3. That's all you do. So f of -3 is equal to -1/3 times -3 minus 5. So f of negative 3 is equal to, those two 3's cancel out, and the negative times the negative becomes a positive 1 minus 5. So f of negative 3 is equal to negative 4. And this is part D, D. If I ask you to write this as an ordered pair, what went into the function is x. What came out of the function was y. So to write that as an ordered pair, it would just be negative 3, comma, negative 4, because your ordered pair always goes x and y. 1a. 1a just gives me a set of points. 2, 3, 0, 0, negative 1, negative 5, and negative 2, 6. So they ask what the domain is. The domain is just a list of x values. So that list, all of the x values, you want to go from smallest to largest. So let's first make the list. So the x values are just 2, 0, negative 1, and negative 2. So you always want to go from the smallest one. The smallest one in this case would be negative 2. The next largest would be negative 1, then 0, and then 2. So when I ask what is the domain, this will be the final answer. They're just asking you for that list of x values. If I ask what is the range, the range is just all of the y values. So the y values are 3, 0, negative 5, and 6, correct? So if I put those in order from smallest to largest, smallest one would be negative 5. Then it would be 0, then 3, and then 6. So that's all they're asking. Just what is the domain and range. Now, if I want to do it's called a mapping, and I'm not asking you in this question, but I want to show you what the mapping for that would look like, because it helps define the next portion. So a map of those points looks like this. 2, again, this is the domain, or my x values, and over here is my range, or my y values. So if I go through and put the domain piece in, I had negative 2, negative 1, 0, and 2. The range was negative 5, 0, 3, and 6. Those are all of the pieces that I have. So negative 2 was my input, and negative 2 went to 6. And then I had negative 1, and negative 1 goes to negative 5. 0 goes straight over to 0. And the last one, 2, went to a positive 3. So that's just the map of all of the ordered pairs. So when we map these, we always have to go through and back with what the point was, right? If I looked at the ordered pair, right, the original ones, the ordered pair is negative 2, 6. So the -2 has to go to the -6. The mapping is just the list of an ordered pair. Where down here, this is called a map of how they go to each other.